So this is lesson 10.1b. We're going to continue our study of solving trig equations, but today is an intermediate level equation, so it requires a little more prep work up front before it turns into a basic equation. And our focus today is how can I recognize the different forms of the equations so that I can employ the proper strategy for solving them. Now, here's what I mean by that. It's quite possible today that you'll be presented with a sine squared theta. And when you solve a sine squared theta, it's different than solving an equation that is just sine of theta. So your algebra skills are going to be really handy. Okay, so you just have to learn to recognize, oh, this looks like it's kind of quadratic, so maybe I should try factoring to solve this equation. Versus it looks linear, I'll just use two-step equations and I'll solve that real fast like pre-algebra. Okay, so here are the steps. Step 1, and there's going to be 3 steps, so let me add a step there. Okay, so step 1 says this. You're going to solve the equation so that it's in this format. Your trig expression on the left and a number on the right, like yesterday. But today's problems are a little more complex, so it's quite possible that you will have multiple trig expressions, and you'll probably want those to equal 0. And then you'll have to use your algebra skills to find the zeros. All right? And so that is step 1. You want to get it so it says sine of theta equals half, or sine of theta times cosine of theta equals 0. Something like that. Number 2 is you're going to find values for theta or x, etc., that satisfy the equation. So that's when we'll start drawing pictures on the unit circle. We'll think about, is this a 30-degree angle, 45, 60, 90, whatever. And we'll have to use some of our trig knowledge to support us in that step. And then step 3, there is an additional step. Anytime you introduce multiple trig expressions in a single equation, you have to check solutions for the multiple trig equations. Okay, because it's possible, I don't know if it's going to happen today on your assignment, but it is possible sometimes that you'll get an answer that's extraneous, and you have to toss that answer out because it doesn't make the equation true. Now, most of the time, if your equation equals 0, as long as one of the 2 trig expressions makes the equation equal 0, then you're good to include that in your answer. Okay, but say as you got the sine of theta times the cosine of theta equals 1, or something like that, then you would have to check both of your solutions or all of your solutions to make sure they're right. Okay, so here's some things to think about. I'm going to get my red pen. Watch out. I'm going to put some eyes here. Watch out. That's a weird picture. Remember that your sine of theta solutions have to be within the range -1 to 1. Same thing for your cosine of theta's solutions. So if you see something like this, the sine of theta equals 3/2, and that might happen today in your homework. What you need to go is, wait a second, how can the opposite side of a right triangle be longer than the hypotenuse? Isn't the hypotenuse always the longest side of, right? And so you're going to have to say, That does not exist. That's outside of the realm of my solutions. So be really clued in. If your fraction is improper, your numerator is larger than your denominator, that can be a sine or a cosine. Other things that maybe, we'll say we go cosine of x equals the square root of 2. Well, if you're thinking the square root of 1 equals 1, right? Right? The square root of 2 is bigger than 1. So if anything over a square root, under a square root, more than 1 is a value that's more than 1. Square root of 7. That's greater than 1. Okay? So just be on the lookout for that and just make sure that, so that's not true, that you're staying within the confines of your sine and cosine function. Remember, they're waves, right? So your answers have to be within that bottom, the trough of your wave, and the peak of your wave. Also, I would like to just continue to emphasize, it's really important for you to learn your relationships for your special right triangles, place them on the unit circle, learn all of those coordinates on the unit circle, because that will make these problems just get harder and harder, progressively harder. So continue to practice and learn those things. I also would like to just remind you of a couple of algebra strategies that you're going to be you will be employing for these amplitude changes and these vertical shifts up and down. Okay, I won't introduce phase shifts today. That's pretty advanced, or period changes, because that's a little more advanced as well. But you will employ strategies, say, like for a linear equation. Say you have the linear equation 2x minus 1 equals 5. What would you do to solve for x? What? Isolate the variable, right? So you'd add and divide, right? So x equals 3, right? 6 divided by 2, right? So that's just your basic pre-algebra skills. I can isolate x by solving this linear equation. I know it's linear because it's x to the first power. If I were to graph it, it'd graph a line. So that's one algebra strategy to think about. Here's another one. If I had something like this, x squared plus x equals 0, this is a quadratic equation, so the way I solve it is different than a linear equation. In this situation, there's a couple things I can do. I can factor. I can use the Pythagorean, not the Pythagorean, the quadratic formula. I can complete the square, although I dare you to do it. That'd be dumb. Don't use the completing the square. That's not efficient. In this case, I also couldn't use the square root property. I would factor, right? And find the zeros. So I would use my factoring skills, or I could use the quadratic formula, but that takes longer. So my zeros are x equals 0 and x equals -1, right? So you can use those same strategies. This will prep your equation and change it from like an intermediate equation to a basic equation if you can employ these skills. One other one I'd like to mention is this. Say I have x squared equals 7. It's also quadratic in nature, which means I could try to factor it or use the quadratic formula, or I could employ, in this case, the square root property. And that's what I would do, right? Solve for x, right? Plus or minus the square root of 7. Please grab your red pen and go, don't forget, when I take the square root of something, I take the positive square root or the principal square root and the negative square root. And then I would suggest that you separate those answers, especially when you're solving a trig equation, because you want to be able to see all of these solutions on your unit circle. That typically will create 4 angles when you have equations like this. When you have a quadratic, 4 angles you're looking at, not 2. So those would be the intermediate level strategies that you would use in order to solve these problems. So let's take a look at problem 1. It says find the solutions of 2 cosine theta plus 1 equals 0. If theta is in the interval 0 to 2 pi, and theta is any real number. I'll do A, you do B. Okay, so I have the equation 2. That's an amplitude change, right? Right, my amplitude changed from 1 to 2, and that's a vertical shift, right? Okay, so these are vertical actions, which means it's pretty much an intermediate level thing. But what I'd like to do is change this to a basic equation. So remember step 1. Solve it so you have the trig expression alone on the left and a number on the right. So you could employ some strategies. You don't have to write this down if you don't want to. You could just look at it and think if you want to do this or not. You could say, I'm going to let the cosine of theta equal x, and I could change the equation so instead it would say 2x plus 1 equals 0, just so you can think about how would I solve that equation, right? Right? So I'm going to solve this equation exactly the same way that I would this equation. So just think of cosine of theta as your x, and what you want to do is isolate it. So the first thing you would do is subtract 1. So 2 times cosine theta equals -1. Divide 2. Basic equation. The cosine of theta equals -1/2. That was just on your quiz. I think it was. So that's step 1. Now step 2, I'm going to draw a picture over here because I think I wrote too big. I'm going to plot on the unit circle where I believe this exists. Now remember, cosine of theta is your x coordinate, correct? Cosine of theta is the x coordinate, sine of theta is the y coordinate on the unit circle, right? I've told you this before, right? Cosine theta, sine theta, that's true. So my x coordinate is -1/2. That happens on the left side of my coordinate plane. So I'm drawing an angle on the unit circle for where x equals -1/2. So what angle measure am I looking at right here? Say this is a 1 and this is a 2. That's the 60-degree angle. So there's my reference. So that means I'm at a pi over 3. And over here in quadrant 2, this is 2 pi over 3. And down here in quadrant 3, that's 4 pi over 3. So those are my two values for theta. So the answer to A is this. In 1 revolution, theta is equal to 2 pi over 3 and 4 pi over 3. And that's in 1 finite interval of 0 to 2 pi. So if I were to draw it on a coordinate plane, I would just draw from here to there. That's it. And I'd be looking for those two answers right there. Okay? All right. You do B. Theta is any real number. So now I want all the solutions. So Devin, this would be one of those situations where we would go, are they on the same line? No. So we would do plus 2 pi n for each of them. So 2 pi over 3 plus 2 pi n and 4 pi over 3 plus 2 pi n, and state that n is an element of a set of integers. Okay? All right. We have 10 minutes to finish this up. So we are not doing any more B's. No more B's. Let me erase real quick. All right, so here we have question number 2A. Find all the solutions of cosine of theta minus 1 times sine of theta equals 0. Okay, so what strategy would I employ here? Well, when I look at this problem, I see that cosine is to the first power, sine is to the first power, and they're separated from each other, and they both equal 0. So here's what I would do. I'm going to color code here. So I'm going to set the cosine of theta minus 1 equal to 0. Because either this can equal 0, 0 times something equals 0, true statement, or sine of theta can equal 0, and something times 0 equals 0. So either one of them can be 0. Okay, so I have trig expressions, multiple trig expressions on the left and a 0 on the right. For cosine theta, I do have to do a little work to isolate the cosine. So I'll add 1. So cosine theta equals 1. And sine theta equals 0, it's already done. So now both of my trig expressions are step 1 is complete. Step 2 is to try to figure out on the unit circle where these solutions, what is theta? So remember that cosine equals 1. How many times in one interval? How many times does the cosine wave peak at 1? Once. That's right. And cosine of theta is the x-coordinate, right? So if x equals 1, we're over here on the unit circle. So that's at 0 radians. So I'm at the point 1, 0. And as I go around the unit circle, this is the only time my cosine equals 1. It never equals 1 again. Okay? So be thoughtful about that. So far, I know that, I'm going to grab my red pen over here. Theta, well, I guess I didn't grab my red pen, equals 0. Okay, so I know that. Now, let's talk about where sine of theta equals 0. Sine of theta is my y coordinate. Y equals 0 right here, right? So is this my sine of theta, or my sine of 0? Is 0, right? Is that the only place that exists on the unit circle? Or does it also exist over here? It also exists at pi. Here's the sine of pi, right? So we have the cosine of 0 is 1, and the sine of 0 is 0, and the sine of pi is 0. So I have 3 solutions, where 2 of these solutions are the same radian. So here's what I want to know. So I know that if I do cosine of 0 minus 1 times sine of 0 minus 1, I'm doing 0 times 0 equals 0. That's true. But if I plug this one in over here, the cosine of pi minus 1 times the sine of pi equals 0, well, the cosine of pi is negative 1. Negative 1 minus 1. And the sine of pi is 0. Does that equal 0? Yeah, so that's true as well. So basically, what's true for this equation is that theta can equal 0 or it can equal pi. So and they are on the same line, right? Diagonal, they're pi apart. So what's my solution? Theta equals pi n. I'm going to start by saying this because you didn't really answer me like I thought you would. So 0 radians, that's the smallest value, plus pi n. And then I would ask you to simplify that. The answer is pi n. Okay? And of course, n is an element of integers. So there's your solution to that one. And I did a little check right there to make sure that both solutions worked. Okay, let's look at the backside. Backside's not very hard. Okay, these will go pretty fast. Here we go. So find all solutions of sine alpha plus sine squared alpha equals 0. This is quadratic-like in its format because you have a sine squared. And I just want to remind you that sine squared theta is the same as, or not theta, alpha, the sine of alpha times the sine of alpha. Okay, so just a reminder, because that's kind of weird notation, you probably want to put the squared on the other side of alpha, right? But it's the sine function that you're squaring, not the angle. You don't want to square the angle, because if you square pi over 3, you get pi over 9. You don't want to do 2 pi, no, pi squared over 9. You don't want to do that. Okay, so what strategy would you employ? Here's things you could do. You could let sine of alpha equal x and just substitute that in so that you can plan things out. So you could say x plus x squared equals 0 and think about, okay, how would I tackle this problem? I would factor it. In fact, I may rearrange it so that it's more comfortable for me and start with the largest exponent and kind of trickle down to the lowest exponent. So I would factor that. Are you guys okay with that? So I'm going to come over here and I'm going to use my same strategy. I'm going to rearrange sine squared alpha plus sine alpha equals 0. And then over here I would factor out an x. So over here I'm going to factor out a sine of alpha. So sine of alpha times sine of alpha equals sine squared alpha. And sine of alpha times 1 equals sine alpha. So there we have it. We've factored it down, so all our alphas or sines are to the first power. Then we find our zeros. So sine of alpha equals 0, which we just solved, thank goodness. And sine of alpha equals -1. Are you good with me solving that in my head? Right, we've done it so many times. And then pop down to your unit circle. We have already decided that at 0 and pi, your sine is 0, right? So there we have 0 and pi as solutions already. And then the sine of alpha equals -1. That only happens once on your unit circle down here at 3 pi over 2. So at 3 pi over 2. So how would I write that solution? I have two of my solutions on the same line. So I could say at pi n, alpha equals pi n, right? But that's not my only solution. I also have another solution down here. And to get from here back to here, I have to add 2 pi n. So I really want to emphasize as well that it's important to kind of model what's happening on your unit circle so you can figure out if you're adding 2 pi or pi. Don't forget n is an element of your set of integers. Now listen, this one goes really fast. So here we have another quadratic. Secant squared alpha equal -4 equals 0. Again, you could say I'm going to let x represent secant of alpha and write this. X squared -4 equals 0. And think about what strategy you would use to solve that and use that strategy. How many of you want to add 4 and square root? Right? So I would say, okay, so secant squared alpha equals 4. I added 4, right? Square root. So that would be secant of alpha equals plus or minus 2, right? Square root 4, that's 2. True? Here we go. Oh, man, we're going to run out of time. Here's what I'm going to do. Secant of alpha equals 2. Secant of alpha equals -2. Don't leave until I do this. Change it to cosine equals half, and cosine equals -half. And then you guys have already solved that one multiple times. We solved this one on the front side, right? It'll have two solutions, one answer here and one answer here, and then in the opposite quadrants. So two solutions. I will load the completed notes to Canvas so that you can finish this out. Listen, your homework is 20 to 34 even, and it is on evens on Canvas. Have a good day.